Welcome to my YouTube channel Kalam Academy. Friends, already we have studied the mathematical modeling of vibrating system, how to convert the physical system to mathematical system. So friend, here mathematical modeling example case studies we are going to study in this video. So number of videos are there. Watch it on my channel Kalam Academy. And here bicycle. See, this is the bicycle. This is a two-wheeler. That is a motorbike. And this car just quarter car. It's how the quarter car and how we can do the physical systems or these actual models into physical system in mathematical model. So, and what you learn after watching this video for this bicycle, two-wheeler and quarter car, after completion of this video, you are going to understand the introduction to physical mathematical modeling, and after that learn analysis vibration problems and steps to find out the replace the physical system by a mathematical model. What are the different steps you will learn? After that, the mathematical modeling for the bicycle or the two-wheeler, that is the motorbike, we are going to study here how to develop this mathematical model. Here, the case study of the mathematical modeling of the quarter car you are going to learn. In this slide, introducing the physical and mathematical modeling, you must learn what are the physical model and the mathematical model. Mathematical modeling from physical model of vibratory system we are studying here. So in real life, most structures and machine systems have elastic members with the dynamic system, hence have an infinite degree of freedom. Already we have studied in degree of freedom video. We can watch what are different type of degree of freedoms. For such vibrating system, physical system, the dynamic system for which the variables are there, that is the excitation and responses, and which are time based. These are time based responses and excitations are there in each vibratory systems. Okay. So response of vibratory system mainly depend on what? Their initial conditions and the external excitations. So these vibratory systems are very complicated and hence they are difficult to analyze, and to solve problem solving of such vibratory system I need to do analysis very properly. For that reason, physical system is converted by drawing mathematical model. Okay. So in engineering problems or various machines or the various whatever the machinery we are using, they are having infinite degree of freedom. So that problems maybe we can say when there is a infinite degree of freedom, that will be the continuous system, or we can distributed system with the complicated differential equation, and we have to replace that complicated equations into simple solutions with the solutions, simple equations with solution. These differential equations become accurate and we can solve and analyze that the continuous system, which is difficult to analyze, and hence they are generally analyzed by converting them into discrete or lump parameter system. So this procedure of modeling is same for all engineering fields. Okay. So, but the details of modeling varies with the field. Whatever the field is there, according to that, the modeling will be different. So we'll study in different video the different modeling system. Okay, what is the lump parameter system? We'll see now. In this lump parameter, helpful by considering or converting them into concentrating them into individual property of vibratory system. Individual property of vibratory system. To replace this physical system by mathematical model, different 4 steps are there. Okay. So these 4 steps I will show you one by one. The following procedure. First step is what? Conceptualization of the physical problem into mathematical model. We'll go in detail in this one. Second is the derivation of the governing equation of differential equation of motion. So this we have to derive the governing equation for this mathematical model, and this mathematical model were formed or drawn by using this physical problem or physical system. Okay, the physical model were converted into mathematical model and were derived this governing equation or differential equation for this mathematical model. And now what? After this got the equation, we solve the governing equation for a specific whatever the conditions are given, boundary conditions, or the what are the external forces are there by using the various methods. Okay, and lastly, interpretation of that solution obtained in a step 3 and its application in design. That is the 4 steps. We study one by one. The steps of this vibration analysis of the vibration problem usually involves following steps. First is the conceptualization of the physical problem into mathematical model. That is the physical model going to convert into mathematical model. And here what will happen in this step? This is a very basic step. Okay, while converting the physical system mathematical system, its main purpose is to represent all the important features of the system for deriving the mathematical equations. The behavior of the system without making the complicated. The mathematical equation of governing equation will get it by considering all its features. Mathematical model may be linear or non-linear. Here, decision to be taken whether the structure should be treated as a continuous, that means the multi-degree or infinite degree, or some standard degree, number of degrees. And with the advantage of considering the lump parameter system, means what? All the features were to consider of that system. With the degrees of freedom we have to finalize. And we will have the location of the lump masses. Also the excitation causing it must be given. What are the excitations? What are the responses? How is the response due to this excitation causing? And that mathematically feasible form, that we have to just decide it. So what will happen then? That by using the Fourier analysis also we can solve this conceptualization physical problems. So here this mathematical model may be linear or the non-linearity with the equation that depends on the behavior of the components of the system, means whatever the different parameters we are considering for that mathematical model, that is considered. Okay, so next step is what? Deriving the governing equation. Derivation of the governing equation or in the form of differential equation. This could be done by first principles of dynamics. It's based on this first principle of dynamics to derive the equations that describe the vibration systems. Both equilibrium method and energy methods can be employed for this one. So resolving the forces couple by drawing FBD, means free body diagram of masses, is considered, and equation of motion is derived by considering all the mass, inertia forces, reactive forces, or the external forces, etc. The choice depends upon the convenience of the resulting the analysis. Whatever the forces and masses are given, that will be, that system may be linear or non-linear, that may be discrete system or the continuous system, and according to that system we have to just derive the equation of motion. That equation, suppose the discrete system, that equation becomes the ordinary differential equation, or suppose in continuous system, that equation becomes the partial differential equation. Under this deriving this governing equation of motion approach, various approach we can use. We can use the energy method or this FBD energy method or the FBD or the equilibrium method we can utilize. Next step will be the solving the governing equation of specific boundary condition and external forces. Means what this in this third step, that will be whatever the surrounding problems while solving this problem solving in vibration system with the high degree of freedom and complexity is there in the system. Suppose to solve it by governing equation by using the various techniques are there, that Laplace transformation, matrix method, or numerical method. Like these, the various considering this initial condition, we can form that utilizing these various techniques, we can solve that governing equation. For some complicated equation, computer programs are also used for the calculation purpose. It is not possible and difficult to conclude the behavior of the system by using the that will be easier by using this computer programmings. Okay, so response of the physical system is obtained by solving that equation, that is in step 2. So it may be necessary sometimes to use the transforms like a Laplace transform to solve the equation, or the multi-degree system harmonic solution for the each mass may be assumed to natural frequency determined by the matrix method also. Friends, last step is the interpretation of the mathematical this equation or results. Whatever after getting the solutions, these results or solutions obtained in step 3 and its application in design, and as a vibration as an applied science, results obtained after the solving the mathematical model equation of motion. The solution of the governing equation gives the suppose the displacement, the amplitude, we can say the amplitude, and after we can calculate the velocity. Similarly, we can calculate the acceleration, time period, frequency, natural frequency, different masses of the system can be found, and the analysis of vibrating system can be done by using the above results. So friend, like this we can solve the mathematical modeling equations. This mathematical vibrating system, before considering, already I have shown that lump parameters. So what is the lump parameter? Most of the structural machine systems have the elastic members. Okay, hence the finite degree of freedom of such system are referred to as continuous system or distributed system, and analysis of this system requires the complicated differential equations. So what will happen? This solution of this differential equation of complicated equations would give the accurate results. So however, the continuous systems are difficult to analyze, and hence they generally analyzed by converting them into discrete or lump parameters. In simple language, दोस्तों मैं आपको बताता हूँ, this continuous system means what? The infinite degree of freedom. Okay. For this purpose, suppose this is the one of this part of that system. Okay. This part is converted into simple the discrete lump parameter. We can say the discrete system. This continuous system is having the multiple degree, but here only 1 degree of freedom. That is conversion of this mathematical model. While converting this one, it is useful. So this step is very important. As the name suggests, the lump parameter system concentrate the individual property of the vibrating system. Means the last that shown you, this is the one rod. Okay, it is converted into spring mass system. Okay, that this delta is the displacement. So it is converted how the is can say here this lumping property of mass would be considered that complete mass concentrated at the center of gravity, and on similar lines the property of elasticity can be considered by lumping the elastic responses. So what we have done here, we have just converted this system into simple this procedure of vibrating system replaced by the physical system and mathematical model. So by converting this continuous system into discrete system, that's why converted the physical system into mathematical model for the getting the solution. So like in this, that rod is considered with the property of elasticity with stiffness K and the mass of this lump property of the elasticity. Using this method, any practical system can be broken into various elements, thereby reducing the complexity of differential equation, and carefully development of the mathematical model would give the reasonable accurate solution. And here, see, this continuous system, if we write one equation for this system, so that equation may be difficult to solve, but for this system it is very simple. Differential equation will got it. Most of the elementary kind of the continuous system would be an elastic rod, that is the shown in this figure A. Okay, this figure A. This bar can now be converted into lump parameter system by concentrating the mass, this mass concentrated here at the center of this bar. An axially loaded bar, the axial deflection of the self weight would be given. So this K that will show it's a self weight. Okay, and this system is converted like this. This distributed one, the lump parameter system. So this del, how can calculate for this continuous system elastic rod with the cross-sectional area A, modulus of elasticity E, and its mass is m. And how to find out this deflection del? By using this formula mgl by AE. That means the W into length of this elastic rod in denominator AE. How to find this K? We can find out W by del. That means AE by L. Here W get cancelled and AE by L is remaining. This cross-sectional area, modulus of elasticity, and length of bar, and that equation we can derive by all this lump parameter. Okay, so friends, now to do the case study of the mathematical modeling of bicycle. During the mathematical modeling of bicycle, it is possible to distinguish between the different approaches, and that different approaches solving this, some consideration must be there. I will show you the side view of bicycle model shows here in this diagram. See, this is the simplified model of bicycle with the rider shown on in this figure. By weighing each of the section of the following rules: mass, spring, contact, where is the physical model of the bicycle with the rider is on this bicycle. Here, rider mass, wheel mass, shock absorber, and the tire. This K1, K2, all these are just given to you in this figure. This physical system is represented here, mathematical modeling. Step by step, I will explain you. The side view of this bicycle model shows the geometrical and dynamical parameters of a bicycle used in the mathematical model. So that will be clear to you what are its parts. So it is distributed in divided into two parts, that is the front part and the rear part, and this rider part. This rider is there, we have to also consider. So here what will happen, these two rigid parts we have to consider. One is the bicycle with some center of gravity, and this your rider with the some its weight is also we have to consider. So these rigid bodies, we can consider this rider as a rigid body and this bicycle as one of these two rigid bodies are there. And with this cycle is in front part and just in the back, the rear part, just were distributed, okay, divided. But what we have to do here, the modeling of vibration for this bicycle, the rider is treated as a rigid body connected to seat by rheolite joint, here, and this handlebar here, handlebar arm section can be modeled as a spring damper system. So I will show you like this here. This one. There is a dually joint and the handlebar spring mass damper system here. Again, this seat, under the seat, the spring and damper is considered. Okay. So the complete system is represented by mechanical system, and again for this front and rear, the front and rear, there is again it is considered the spring, and with this consideration of this rigid body, there is a saddle with the central frame, whereas the spring damper system is considered, and the tire of wheel and seat and handle are converted into like this one, the model. So this considering this handlebar arm and this sitting arrangement and the tire and this wheel for front and this rear, that is they are considered, and they are modeled with the diagram like this. Okay, so this is the weight for this rider MR, weight for this total cycle MW, and with the springs and they are considered here in this diagram. In this case, the springs are considered. So we have got the mathematical model here for this bicycle. So we can mathematical model of bicycle. We can get the equation from this mathematical model, and here the stiffness value for this seat, or the stiffness value for the tires and city, we can find out, and the dumping of the seat we can consider, and for the seat tire we can also consider the damping of the seat and tire. Handle arm, this handle arm damping also we can consider. And this mathematical modeling of this bicycle is also helpful for converting the infinite number of unknowns into finite number of unknowns. Just whatever the unknowns are there, just distributing it and we are calculated. So friends, this is the mathematical modeling for the bicycle, and only this vibration excitation to this bicycle comes from the unevenness of the road surfaces. So the ground, it is not even, it is uneven, so that will be create the excitation in this vibrating system. And this is the mathematical modeling of the bicycle. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes. And friend, here you always learn by self-assessment only, and you have to subscribe my channel Kadam Academy. If you are not subscribed, please subscribe it. Thank you very much.